Hello, Gen Chem students. I wanted to take another crack at explaining formation reactions. A formation reaction is a special type of chemical reaction in which the goal is to simply form 1 mole of your compound of interest from its constituent elements. Those elements are going to be listed as the reactants in their standard states, so whatever state they're in under 1 atmosphere of pressure and at 25 degrees Celsius. Most elements are solids. This will be things like carbon, phosphorus, any of the metals on the periodic table. Anything that is a gas is probably going to be a diatomic gas. These are things like hydrogen, nitrogen, chlorine. They will exist as H2, N2, Cl2. And then there are only a few elements that are liquids under standard conditions. These are mercury, which is monatomic, and bromine, which is diatomic. The delta H that we associate with a formation reaction is the heat of formation, delta HF. The little ordinate symbol in the upper right-hand corner tells you that this is something that's occurring under standard conditions. That's that 1 atmosphere of pressure, 25 degrees Celsius, and unless otherwise specified, a concentration of 1 molar. To write a formation reaction, you will write 1 molecule or formula unit of your compound as the product. You will list the component elements in their standard states as reactants, and then you will add coefficients to balance the atoms. These coefficients will frequently be fractions, and this is perfectly fine for formation reactions. Let's take a look at a couple examples. Our first example is sulfuric acid, H2SO4. This has 3 elements in it: hydrogen, sulfur, and oxygen. Hydrogen and oxygen are diatomic gases in their standard states, whereas sulfur is a solid. Let's write down our original equation. H2 gas plus S8 solid plus O2 gas will become sulfuric acid as a liquid. Now we need to balance this equation. We're going to take a look at each side and see how many atoms of each element is present. In the reactants, we have 2 hydrogen, we have 8 sulfur, and 2 oxygen, whereas in the product, we have 2 hydrogen, 1 sulfur, and 4 oxygen. In order to balance the hydrogens, we don't need to do anything. There's already 2 on each side. However, we've got 8 sulfurs in our reactants and 1 in our product. Therefore, we're going to have to put a coefficient of 1/8 in front of the S8 to balance. The oxygens, we've got 2 in the reactants and 4 in the products, so we're going to have to put a coefficient of 2 in front of our oxygen in the reactants. If we do that, we get a final equation of H2 gas plus 1/8 S8 solid plus 2 O2 gas goes to 1 molecule of H2SO4 liquid. This is a balanced formation reaction of sulfuric acid. One more example. Manganese 4 nitrate, or MnNO3-4. We're going to start by writing down 1 formula unit, which is the MnNO3-4, as our product. It's a solid. And we're going to need to write down the manganese, nitrogen, and oxygen in their standard states. So we've got manganese solid plus N2 gas plus O2 gas becomes manganese nitrate. We're going to do our atom check to see how we need to balance this. We've got 1 atom of manganese in both the reactants and the products, so that's balanced. The nitrogen, we've got 2 atoms of nitrogen in the reactants and 4 in the products, so we'll need to multiply our N2 by 2 to balance. And lastly, there's 2 atoms of oxygen in the reactants, but 12 in the products, so we will need 6 molecules of oxygen gas. If we write all of this out, we get manganese solid plus 2 N2 gas plus 6 O2 gas becomes 1 formula unit of manganese 4 nitrate solid. I hope this clears things up. These formation reactions are useful because we can add them together to derive the heats of reaction of more complex systems. I'll see you guys next Monday for Exam 3 review. Happy Thanksgiving!